we are going to start out with one of my absolute favorite types of problems. It's just problem solving, and it's pigs and chickens, and you'll understand why once we start to do this one. But before I get too far along, I want to explain the reason that I like this problem so much is because it shows a very clear example of how there is more than one way to solve a problem. And the approach that you should use is the one that makes the most sense to you. This will be a theme throughout our course. Keep in mind, the approach you use has to be valid. It has to work every single time. It has to be based on a solid mathematical approach. But you don't have to use one single approach to solve a problem. I hope that's something that you will pass on to your students when you're teaching. Let's take a look at this. A farmer owns pigs and chickens. When looking into his field, he sees 10 heads and 28 feet. How many pigs does he own? Well, if you've been sort of trained the way that I have to think of most things in terms of algebra, then that's the approach that you would probably lean towards here. And I think algebra is a great way to go. We have a certain number of pigs, and when we add that to the number of chickens, that's going to be 10, because there are 10 heads. And each pig has 4 feet, and each chicken has 2 feet. So 4 times the number of pigs plus 2 times the number of chickens will give us the number of feet. And now we have 2 equations and 2 variables, so we can solve this system of equations. Hopefully you remember that from algebra somewhere along the way. The way that we're going to do this is using something called substitution, which I hope you're familiar with, but if not, you're going to see a couple other ways to go about this type of problem in a few minutes. The first thing we need to do here is get one variable by itself so that we can substitute. So I'm going to take this equation here and rewrite it so that P is equal to 10 minus C. We get that by just subtracting C from both sides. On the left side it cancels, on the right side we get 10 minus C. Now that we know P is 10 minus C, we're going to substitute that in for P in the other equation. So we're going to have 4 times, we're not going to write P, we're going to write 10 minus C plus 2C equals 28. And then we're going to solve this. So I've got to use the distributive property here to multiply, and I'll have 40 minus 4C plus 2C equals 28. I've got some like terms to combine. I've got 40 minus 2C equals 28. I'm going to move over here to finish this thing up, and I'll stick with the yellow. Well, if I subtract 40 from both sides, I'll see that negative 2C is equal to negative 12. Divide both sides by a negative 2, and C is 6. That tells me I have 6 chickens. Now there's a couple of ways you could finish this up. You could say, well, I know there were 10 animals altogether. If 6 of them are chickens, then 4 of them must be pigs. The other way is, well, I had this right here that told me that P is 10 minus C. So once I know that C is 6, P is going to be 10 minus 6, which is 4. The question was, how many pigs does he own? Well, since he has 6 chickens and 4 pigs, the answer to that question is 4. That's one approach, the algebra approach. Some of you may think that's great, some of you might prefer something else. Let's look at something else. The most important part of that problem was that there were 10 heads and 28 feet, and we're trying to find out how many pigs there are. So starting from there, what if we just tried trial and error? Some people don't think trial and error is a valid method, but it absolutely is. In addition to being a way to solve a problem, it can give kids a real number sense development, which is fantastic. So let's take a look at this. Well, I'm told there are 10 heads. Well, what if I say that I just split it right down the middle, and I've got 5 chickens and 5 pigs? That would be 10 heads, so I've got that part right. Now how many feet would this be? Well, the chickens each have 2 feet. So this would be 10 feet if I did it that way. And the pigs, if I have 5 of those, a pig has 4 feet, so that would be 20 feet from the pigs, which altogether would be 30 feet. That's too many. I'm only supposed to have 28. So I need to have the same number of animals, but less feet. Okay, well, with that in mind, if I need less feet, I'm going to increase my number of chickens, decrease my number of pigs, and see if that works. Now I've still got 10 heads because I've got 6 of these and 4 of those, so that works. Now, with 6 chickens, that would account for 12 feet. And with 4 pigs, let's see, 4 times 4, that would be 16 feet. And I've got the 10 heads that I wanted. I've got the 28 feet that I wanted. So this must be correct. I must have 6 chickens and 4 pigs. Some of you might be thinking, why in the world did I do algebra if I could do this instead? Well, that's a good question. Of course, if the numbers were bigger, trial and error might be a little more challenging, but there's nothing wrong with using trial and error as a problem-solving technique. Let's look at one more. I have to be honest, this is a way that I would never have thought of, but my kids would. And your students likely will. So let's take a look. I need 10 heads and 28 feet. Well, how about if I draw 10 animals, and so these represent their heads. So there's my 10 animals. I'm just going to start by making them all chickens. Every one of them has 2 feet. Okay, so I've got my 10 animals. I'm making them all chickens so that every one of them has 2 feet. Well, how many legs is that? That's 20. I need to have 28. So what I need to do is turn some of these into pigs. So I need to add 2 more feet to the ones I'm turning into pigs. So I'll add 2 feet to there. Let's see, how many feet did I have? I started with 20, so now I have 21, 22, 23, 24, 25, 26, 27, 28. I've got 10 heads. I've got 28 feet. How many of these are pigs? Well, these right here are the pigs. So I've got 4 pigs and 6 chickens. A perfectly good way of going about solving that problem. I gotta be honest, I would have never thought of it, but I love it. I think it's fantastic. Moral of the story is, I love this problem because it's a good problem and because it's a great illustration that there's more than one way to go about solving a problem. As long as your approach is valid, reasonable, and repeatable, feel free to use it.